Okay, today we're doing inverse trig functions.
Are you recording?
Not reciprocal functions, but inverse functions, okay? So don't get in your head, we're talking about secant, cosecant, and cotangent. That's not what we're doing. Okay, inverse trig. So this is like, it says, with all the functions, the inverse of a trig function is the result of switching input and output. Okay, if you look at my board right now, what you see up here is Algebra 2, inverse functions. That's all we're doing in Algebra 2 right now. Swapping x and y, solve for y, get the inverse function.
So is this x over y instead of y over x?
Not necessarily.
It's the thing we did where you just swap the x and the y over the u.
Yeah, solve.
Get y by itself.
Okay, so these are inverse functions. There's two ways that we write this in trig form. One is to say sine inverse of x. Sine inverse, and that's the most familiar to me. I will call it sine inverse all day long. And another method is to call it arc sine. Those mean the same thing. I hardly ever would say arc sine. But you need to recognize both because both mean the same thing and they can both be thrown at you.
How do you say that?
Sine inverse. Sine inverse. So it's not sine to the negative 1 power. This is said sine inverse. And the other one is called arc sine. And you say it like it's red. Arc sine. Okay. Well, I actually had kiddos several years ago. Miss Nava was a huge arc sine person. Like she would say arc tan, arc cosine, arc whatever. And they were sitting in my class and they would talk like that. And I was like, I much prefer sine inverse or cosine inverse. But they mean the same thing. So it's a familiarity thing. It's not right or wrong. Okay. We would say arc sine of x when reading it out loud. Oh, they say with either notation. I say sine inverse. Okay, maybe I'm wrong. I don't know. I
Say arc sine.
think we say sine inverse also. I don't know. Whatever.
I've only heard sine.
Okay, with the statement sine of pi over x equals 1/2, we want to write that statement in an equivalent form using arc sine notation. So what that means is we're going to switch x and y. So an equivalent statement here would be to say sine inverse of 1/2 is pi over 6. Okay, so what are we finding here?
The inverse.
Okay, so let's think about this. If I have sine of an angle theta, that gives me the y leg length, right? Sine of the angle gives me a leg. So if I take sine inverse of a leg, I'm finding the angle.
So they give us
It gives us the angle. Okay, not angel, but angle. Are we clear on that?
Yeah.
So if I say sine inverse of half,
that'd be
the answer here is
3 over
pi over 6. Pi over 6. Yeah, but it could have been in, I'm going to give it to you. It could have been in quadrant 1 at pi over 6. Where else is sine inverse half? Or where else is sine inverse of half?
That's a great question.
Oh, man, I was trying to throw it to you.
Another one. 3 pi over 2.
Hey, I was gonna say that. No, you weren't. Come on.
Rosalind's got it for the win. 5 pi over 6. Okay, let's keep going. It says restricted domains of inverse trig functions, and this kind of gets a little bit hairy. It says because trig functions are periodic, we must restrict their domains to create their corresponding inverse functions. In order to make the inverse a function, we will restrict the domain of y equals sine x to the domain from negative pi over 2 to pi over 2. The reason we do that is, look, this is before the y values are repeated. This covers every y value from negative 1 to 1. If we go from negative pi over 2 to pi over 2, that covers every y value. Okay, so if that is the domain value, what's the range of this function? No, from negative 1 to 1. So given this domain, our range is negative 1 to 1, right? We're oscillating between those two values. For cosine, we want to make sure we cover every y value. If I go from negative pi over 2 to positive pi over 2, though, I only get the top half of the y values that cosine covers. So that's not good. It's not what we want. Instead, we go from 0 to pi. We know that the range for cosine should be negative 1 to 1. So the domain that corresponds with that is 0 to pi. You see what we're saying here? If I go past pi, then I start repeating. I don't need to repeat. I just need only list repeated numbers once. Okay. So for tangent can go from negative pi over 2, which is that first asymptote, to positive pi over 2, because we see tangent values everywhere in between. Okay, so due to the vertical asymptotes, the domain of the tangent function will go from asymptote to asymptote. That'll catch on all real numbers. Right. Range would be all real numbers with parentheses, not brackets. Good. Questions on that? So this is a little woodsy. Okay, we kind of talk about getting stuck in the weeds, and these, I would call these weeds. Okay, so inverse trig functions. It says, a note about inverse trig functions. It's important to always remember and consider the domain restrictions when we're working with inverse trig functions and values. So they've shaded the domain possible here. The domain here is, the domain is marked by, they're calling it range. Negative pi over 2 to positive pi over 2. The reason that we have this domain restriction is because by the time we get over here, sine starts repeating itself. Okay? So look back at this information we just wrote down. We said the domain for sine is negative pi over 2 to positive pi over 2. So the range for sine would be that. This would be the new domain. No, this is the range. I hate inverse functions. Anyways, well, it'll make sense when we work the examples. It's fine. It says, evaluate the following expression. We want cosine inverse of negative square root 2 over 2. Well, cosine is negative square root 2 over 2 on the left side of the y-axis, because cosine would be negative over there, and at pi over 4 values over here, right? So not positive pi over 4, that pi over 2 would be 2 pi over 4. This one's going to be 3 pi over 4, and the bottom one, 4 pi over 4, this one is 5 pi over 4. Well, which answer is allowed to be the right answer for this particular problem? It's going to be the one that fits in this restricted domain. So 3 pi over 4. If we didn't have a domain restriction here, we could take both answers. Do you understand what we're saying? So it's going to be restricted to be within that shaded area. Okay, so sine inverse of negative square root 3 over 2. So that automatically drops us down into the bottom two quadrants. Either we're in quadrant 3 or 4. We want to be at a long. This is square root 3 over 2. So we want a long in quadrant 4. A long is a pi over 3. So we've got 1 pi over 3, 2 pi over 3. Pi would be 3 pi over 3, 4 pi over 3, 5 pi over 3. Good. 5 pi over 3.
Oh, see, this looks like this might be difficult.
Oh, tangent inverse of square root 3.
So
You just have to remember which quadrant is shaded for each one of these.
And you can find that by imagining the actual trig function themselves, right? Okay, so tangent inverse of square root 3. Now, let's think about this. Tangent is sine over cosine, right? So we need our sine value to be square root 3 over 2. And cosine has got to be what? So that when we multiply by the reciprocal, we're left with square root 3. So cosine needs to be a half. Right? Because when I multiply by the reciprocal, I get square root 3. So where on the unit circle do I have sine pi over or 3 square root 3 over 2 and cosine a half? So we're looking at a short long. Pi over 6. No. It's a short long.
Oh, no, it can't be 1 point.
Pi over 3. Pi over 3. We're saying a short and a long. Does that make sense?
Yeah.
So at pi over 3, and it's a positive square root 3 over 2. So we're going to be in quadrant 1. Tangent's also positive in which other quadrant? Quadrant 3. Okay, so we're talking a positive pi over 3 here. Is that helpful? Good? Okay. All right, example 3, it says the angle theta is in standard position. The terminal ray intersects the unit circle at point P, whose coordinates are x, y, so that's here. The points Q, R, and S are the result of the terminal ray being reflected over the y-axis, origin, and x-axis respectively. For each of the following expressions, determine which labeled point intersects the terminal ray of the given angles. So cosine inverse of x. Cosine inverse of x would be located at point what?
There's no 4.
There's one.
You have one.
He said, I just took a guess. Cosine inverse of x. This is a positive x.
Whoa.
Okay, so look again. Where is cosine allowed? Cosine inverse is allowed to be in quadrants 1 or 2. Where is x positive? At P. Okay, so cosine inverse of positive x. So positive x either happens at P or S. But cosine is allowed to be in quadrants 1 or 2. Cosine inverse. So this is going to be P, not S.
So sine of negative y.
So sine inverse is negative y. So where's not? Now we're in either R or S. Look at your sign restrictions. Has to be S.
R or S?
Negative y.
Oh, so it's reflected across the x-axis.
Oh.
Okay, so cosine of negative x. Now where am I? I'm either in quadrant 2 or 3, but restriction for cosine is quadrant 2. So our answer here is Q. That one was either going to be Q or R. Do you understand now what's happening?
I think so. So it's like with the thing at the top, where it was like shaded, that's like saying that this has to be where x is negative. It's cosine of where x is negative.
Yeah.
Okay.
Because this is what I was telling you earlier, Truett. Look right here. Sine inverse of a leg is theta.
So cosine inverse of negative x.
Is what point?
Q.
Mm-hmm. So tangent, okay, David was saying earlier, tangent is negative in quadrant 2 or 4. 2 or 4. So where's tangent restricted? Can't be 2. It's got to be restricted to 1 or 4. So our answer here is going to be also S.
Why can it not be 2?
Look up at your restrictions on tangent. Tangents.
Oh, so those still apply?
Tangent inverse is only allowed in quadrants 1 or 4. Why? Because tangent covers all the range values between negative pi over 2 to positive pi over 2. So they shaded in on this picture between negative pi over 2 and positive pi over 2. So our inverse function is restricted to this domain only.
But we filled in. Okay, hold on. Yeah, I think.
So tangent inverse is negative in 1 or 4.
Yeah.
Or 2 or 4.
I got my letters mixed up.
It's easy to do. I mean, this is a whole lot of pat your head, rub your tummy.
What's a breath of a?